Hello. Hello.
Hello.
Good afternoon, Rajesh sir.
Good afternoon, everyone. Good afternoon, Kamasaro sir.
Just I'm Umadesh sir, are you there?
I was just trying to call him, sir. He is just
No,
stepped
no
away.
problem, sir. No problem.
Ah,
Welcome, Rajesh sir, our alumni from our SRKR Engineering College. He is one of the pioneer in our. And now I request Janaki Devi madam to introduce our guest speaker, Dr. Sri Rajesh Garu.
Good afternoon, everyone. This is Janaki Devi working as Assistant Professor in the Department of CSE SRKR Engineering College. Thank you for joining us today. It's my distinct pleasure to introduce today's chief guest, Ganapavaru Rajesh Garu, who has made a significant impact in computer vision and image generation and diffusion models and GIN. He is now there to share his knowledge with his real-time experiences. He is working as Senior Manager Compliance IT audits at Infosys. He is having 28 years of experience in industry. He worked as civil engineer at L&T Limited from June 1998 to 2001. Later, he joined as project manager at Infosys in 2001. With this brief introduction, I would like to invite Rajesh Garu to share his knowledge with us. I welcome you, sir.
good afternoon, everyone. Thank you for giving this opportunity. Uh, I think it's a great privilege having graduated from SRKR and trying to give a session to my teachers. Uh, as Ms. Janaki Devi has told about me, let me quickly introduce myself. I graduated from SRKR as a civil engineer, worked in L&T for 1.5 year, and then moved on to IT, uh, working with Infosys for about 23.5 years for now. So I'm currently working in for a financial services client as an senior compliance manager, and I'm responsible for the IT audits here as well as the SOC audits, which are mandatory in the financial services industry. So today I'm here in front of all of you to go through this computer vision, and we'll have a quick and I would like to make it an interactive session here rather than as a lecture. So we will go through this both the topics, computer vision and generation, and then I'll also try to give some real life examples of how we are using this in our day-to-day life, which is relevant to my industry. So as all of you know, in the IT industry, we work with a specific set of clients which we call as vertical industry. So here in Infosys, I have been working mostly with financial services clients. I would like to give an introduction of how this technology is helping us with you know with our industry. I would like to take a few examples, although we may not be able to disclose everything due to the confidentiality of our projects here. So then as we go forward, I would like to take some questions as well. Thank you. Sir, can we get started, sir?
Yes, sir.
Let me switch off my camera. Could you please give me a minute? Let me close the door and come back if you don't mind.
Okay, sir. Okay, no problem.
Can you please confirm when you can see my screen?
Yes, sir.
Yes, sir. Yes, sir.
Okay, thank you. So here I would like to make this session into two parts. One is, I'll go through the presentation which I have prepared here. And then I would like to go with some practical examples of this. And then we can talk about some real life applications of this, followed by a Q&A session. So with this, I'll start the presentation. So when we talk about the literal meaning of vision and image generation, as the word itself suggests, vision means looking at something, right? So this particular topic is all about how do we make a machine look at something and identify and perform something which we would like that machine to do. Okay, so at the face of it, this definition might look like a bland definition, a textbook definition. But as we go through this, you will appreciate the process and underlying process and how do we make use of it. And image generation, as the word suggests, is how to generate an image. So we will look at what is the underlying concept of it, what are the various processes, tools, how do we make use of those tools to generate the images. So we'll go through that in detail in the later slides. So this is what I have been talking about in the previous slide. This is just how do we make AI, artificial intelligence, enable a machine, a computer, to interpret and understand the visual data, which is nothing but an image and video. So here the objective of it is, how do we, I mean, if I show you an image of something, a mountain with rocks, and if I ask a human being, can you just point out to the rocks on the mountain? You'll be able to do that immediately, because as we grow up from childhood, we learn from our real life, from our parents, from our surroundings, from teachers, that what exactly is a mountain, what is a rock, a boulder, how do we differentiate between a pebble, a small stone, uh, versus a boulder or a huge rock, a mountain. What is the composition of all this? How do we, differentiate between them when you look at either in real life or in an image or in a video, right? Although we don't know, there is a lot of processing that happens in our brain that tells us as soon as you see an object that, okay, this is soil, this is sand, this is a pebble, this is a boulder, so on, right? Just by taking an example of a mountain backdrop. Now, for a computer, all it knows is, I don't need to tell all the eminent professors here, the underlying thing for a computer is all zeros and ones here. But how do we ensure that it learns how to differentiate between various things here? So this is where we get into these algorithms and techniques on how do we make sure it learns on differentiating various things. So now, how it actually works, the computer vision. How do we ensure a computer sees the way we see at things and analyze it? First, it's all about within a given set of data, right? It could be a numerical data, it could be an image, right? Within that, how to differentiate a visual data, which is nothing but an image or a video. And then when we talk about the pre-processing, which is mentioned here, it's all about cleaning up the unwanted things. Like for example, if you look at an image, how do we remove the grainy pixels and all, and remove the unwanted material out of it and identify what exactly that particular image is trying to depict, right? And the next step, the feature extraction. How do we identify various edges, shapes, and textures? Like, okay, when you look at image as a human being, right, you understand that, okay, this picture is trying to depict an urban population, an image of a city, right? It shows landscapes or it shows the buildings. So depending on, even if you look at something like a caricature, right, you will still be able to appreciate that, okay, this is trying to depict the skyline of a metropolitan city, like the buildings, right? How do we do that? Because the lines, the contours and features make you think that, okay, this is trying to represent a building. So this could probably be a skyline of a city, right? That is how we extract the features, understand that what it is trying to show there. Then we come to the training here. Now, because it is a machine that we are trying to teach, now how do we make it understand various patterns? How does it need to differentiate between people, inanimate objects, trees, rocks, roads, buildings, for example. And finally, we give it some training and then try to make it understand and analyze that, okay, this is what this particular picture or video is trying to depict. So these are the various steps involved in this. So here is where we are trying to go deep into that. So I will not going forward. I will not make this particular topic too much technical. Rather, I would like to focus more on the process, underlying process, and some practical live examples that we can make use of. Now, what are the tasks in doing this? Now, how do we categorize the image? Does it belong to a person, a city, or an art, and so on? And then how do we identify various objects within that and how to monitor that? And when we come into the practical examples, these terms here make sense for you. So how do we monitor object movement in videos? Like, for example, when we look at a practical usage of this, I think you must have heard of all these things in real life. For example, a police or law enforcement officials making use of videos, traffic cams to identify a specific vehicle. Like, for example, a person has committed a crime and is trying to escape using a car. So these techniques are used in identifying the object first. Like, for example, a car, a four-wheeler. What kind of a four-wheeler? A sedan or not? SUV, so on. Then the color of it, the make of it, and finally the most crucial piece of identifying that vehicle is your registration number, of course. So how do we identify all this within that video? So these features, what we are talking about here, these make sense when we look at a practical example of it, a live example of it, right? So how do we differentiate between the objects and regions in the image? So these two features together, the best example that we can give is the one I talked about. So how do we differentiate when it is running? They look at a series of webcams, a traffic webcams, and then how to identify the same car between different camera videos, the footage generated from them, and identify it is still the same person and how to track it. So that's the best example of that. Coming to the last one, the facial recognition. The practical example of this is again, we can explain again with the same kind of an example, like customs officials in an airport trying to track, a person who is the most wanted person, for example. These are the live examples I'm giving. So we can talk about how to give his picture, feed his picture to the machine and identify him, that person within a crowd. Again, another example that most of you might have used on your own devices, handheld devices, a facial recognition feature in your own mobile phone, right? Some of you might be having a facial recognition feature in your mobile phone. So how does it do that? The first step, you feed the data by showing yourself to the device in various angles, lightings, and in dark mode. I think if you have used that and train your camera, it asks you to show your face in when it is dark, when it is light. and with different angles, side view, top view, and all. And then it tries to recognize you from whichever angle it's trying to look at you and recognize that you are the one that is trying to unlock the mobile, right? So I'll just take a brief pause here. Any questions so far? Okay. So moving on, what are the key algorithms and models that are used for making this happen? So we are in this session, we are not going deep into the technicalities of all. These are the models that is used in the industry. So the algorithms are Hog and Sift, and the learning models are ResNet and MobileNet. So what are these? The algorithms teach the computer on what kind of an algorithm should be used to make it detect and identify a specific object. And the learning models will tell how to refine your analysis and your recognition pattern. When I say yours, I'm referring to the computer. So it tells the computer how good your learning is and how good your analysis is. So when we talk about this in the next slides, you will appreciate, how it does that practically. Okay. So I'll just move on to the applications here. We use these in various industries: healthcare, retail, agriculture, and autonomous vehicles. So we can talk about. I'll just go briefly into a couple of examples of healthcare, autonomous, and live examples from the industry where I work. Right. So when you look at healthcare, just a simple example for everybody. You're playing, you hurt yourself, and you notice that there's a swelling in your feet, right? The first thing that comes to your mind is it a fracture, a twisted ankle, or is it just a bruise? So what do? You go to a doctor. Depending on the kind of injury, doctor might suggest an X-ray or MRI scan, right? Depends on it's a ligament tear kind of injury. They even refer to the MRI scans, right? So what happens next year? You get the film, X-ray film in your hand or the MRI image, right? So you as a non-medical person, when I say you, I'm referring to all of us who are mostly non-medical field, right? So to us, the X-ray just looks like a black and white film, right? Just like any image. Unless otherwise the fracture is too obvious. As a non-medical person, I will not be able to differentiate anything between X-ray of two people, even though it is taken on the same, part of the body. Like for example, my ankle, right? I can't differentiate between two X-rays of ankles taken from myself and another person, right? So to a trained eye, like a doctor or maybe a nurse, right? They'll be able to say that, okay, this is what it looks like. This is a, I think most of you know, each bone in our body has a name. So they will say, okay, this particular piece of bone looks disfigured, or there seems to be a fracture here, whether it is a severe fracture, dislocation, hairline fracture, what all. With their trained eye, they will be able to differentiate. But as a non-medical person, I will not be able to differentiate and tell what exactly that is. Or for the matter of fact, an MRI scan image, I will not be able to tell what it is. And for example, a patient who assume that a person has a tumor, whether it is a malignant tumor, which is a cancer, or non-malignant. How do we know? We can't, right? A trained person can do that. So now what is the real world application of this computer vision? That is where this comes into picture. Now we train the computer into looking at various X-rays, various scan images, and teach how to differentiate between X-ray of a normal person, healthy person, versus an injured person, and try to detect whether that's a real injury or it's a harmless injury. When you look at it, could be an external bruise kind of a thing. Same way with a scan images, any kind of tumors, right? How to detect whether it's a malignant tumor, a cancerous tissue growth, or is it just some kind of a abnormal growth, which is curable. Now, coming to the autonomous vehicles, right? Most of you might have heard of self-driving cars, right? So how does these work? How do they work? They have cameras on most of the times, 8 sides, top, bottom, including top, bottom, 6 sides, everything included. The job of these cameras is to detect images, understand whether they are people, objects, and again, they also need to get trained on how to identify the traffic lights or signals, right? So it should be able to instruct the car to stop if there is a red light, and various other patterns. Like for example, if an ambulance or a police's car is coming, it should give way. So these are the kind of things it should be able to recognize the patterns, understand, and act accordingly. And again, here one more thing comes into the picture of the more number of examples it gets and get trained, as well as the speed of it. Like for example, if you take an autonomous self-driving vehicle, right? Both things coming, are really significant here. How to identify an inanimate object, and also take a quick decision on whether you can pass through or wait for it. Let me take an example here. You are driving. Now we are getting close to the harvest season. Most of you might be familiar with hay or grass, put on the roads for drying, right? Most of you might have seen in the rural areas. So as a human being, when you are driving in those areas, what does your intuition say? Just says that, oh, it's a grass. My car can, drive on top of that. It's a hay, right? A paddy field hay. So they drive that and you are able to take a decision and drive on top of that without causing any damage either to you or your vehicle. Versus, for example, a concrete slab thick enough, to topple the car if you try to drive on top of that. So your brain quickly tells you that, okay, it's a piece of heavy concrete slab, a piece which fell, by an accident or what for whatsoever reason it's lying in the middle of the road, or a big boulder, right? It tells me that, okay, I cannot drive the vehicle on top of that. It might cause my car to topple here. So what does your brain say? Immediately to apply the brake. So the same way, this image, this vision should evolve, and the underlying algorithms should tell that it's a piece of inanimate object which you cannot pass over. You should immediately stop. So those are the practical examples that we have to take when it comes to the speed and the accuracy of it. Let me take another example. Maybe all of you might have heard of Star Wars and automated warfare, right? When you consider these warfare, right, using a machine. I mean, let me not scare about all that, but for all we know, a lot of countries have their own defense systems, correct? So what does these defense systems do? You might have heard of it recently also. I'm not going to quote the names of the countries or their technologies here, but the moment one of the countries defense system recognize that missiles are coming through and about to fall on their country, they launched defensive tactics, right? So how did this happen? And these decisions have to be taken in a very quick fashion. So that is where they should evolve. I mean, let's not go deep into those war kind of scenarios, but at least the self-driving vehicles is the best example that we can talk about. And even then, the decision has to be accurate and quick enough so that it doesn't cause any harm to either a third party or your own vehicle as well, right? And looking at a red light, it recognizes that, okay, it means stop. Right. So these are the various examples that we can talk about how to make these things work and the practical examples, and how do we ensure the speed and accuracy of them go, getting improved day by day. Let me take a pause. Can I just ask anyone if anyone has any question on this? Okay, so I will quickly, talk about one real life example that we have in the industry. Like for example, there are restricted areas where only a selective people are required to enter, right? So then how do you make sure an unauthorized person does not enter that particular area? Here is where your facial recognition comes into the picture. Now you feed all the valid employees photos. Then the second aspect, which is a real life issue that I'm going to talk about. For example, you have access to an area, you swipe your badge, you get access, but instead of you entering that particular area, you allow your friend to enter instead of you. Even that's a security hazard. So there are systems that we are using currently to even detect these kind of anomalies that will throw an alert to the administrator saying that the person who has actually swiped did not enter, but he allowed somebody else to enter that particular area, restricted area. So these are the real practical examples that we are using. And the self-driving cars are also a close reality in at least in some countries. Right? So let me move on to the challenges on reaching this point here. So here, so how do you make computer recognize a certain thing, right? All needs is a data quality. So the quality of the data, whether it has, for example, you look at an image, sometimes it comes distorted the way, just one quick example. You want to share the image with somebody who is the one actually analyzing the data. You're trying to send it over an email, for example, and your email has some kind of a size restriction, and you might want to, send a lower resolution image, right? So what happens? The person receiving that may not get a good quality data to make a good decision or understand what it is. The second one is about real-time processing. Time-sensitive applications, I think I have already covered in the previous slide, the real examples I gave, a self-driving vehicle, a warfare scenario, right? Those are the ones where certain industries need a real-time processing, and it has to be, very quick. And third one is about generalization. So you show two images to a computer, and if they look similar, humans are at least able to identify between what they are. But at certain times, the system is not mature enough to see that it's a different image, especially if it is the new data. At least if you see, if as a human you see a plastic chair, a wooden chair, and a plastic chair that has been touched up with a wooden varnish kind of thing, right? That looks like a garden chair for you, but actually you are able to recognize that it's a plastic chair after all. So these are some of the things that a system may not be evolved much to differentiate. And finally, a hardware limitation, right? For example, you are taking an image, a photo with a 2 megapixel camera versus 16 megapixel, versus even some cameras are coming with 40, even 60 or 80 megapixel cameras as well. So all it depends is a source of data. So these are the certain challenges in making this computer vision evolve and understand and give an accurate result. Okay, and these are the frameworks and tools that are used for computer vision. I mean, as I said, I mentioned at the beginning of the call, not going to go deep into these kind of technical aspects. So you might have heard, I mean, I will not go into the deep. We have discussed live examples already. So the AR, VR, you must have seen in your some of your games, right? Augmented reality. So now we are done with the computer vision part of it. So I will be about to start the image generation part of it. So far I just wanted to check, is the pace of it is fine, or do you want me to stop somewhere, go in depth into some of the topics, or speed up? Can I get some feedback on this so far?
You may go for some more.
Sorry, sir.
You may go for some more deep.
Please, sir. Next topic we have GANs and diffusion
Okay,
models.
sir. Okay,
I
sir.
think
Okay, sir.
since the other topic was there, I was not going deep into this. So pardon me for that. I should have told that in the beginning.
Okay, sir. Okay. Actually, we are having time up to 5 o'clock. You can cover these things.
Right, sir. We have
Okay, sir.
the second topic again at 3:30.
Okay, sir.
Okay. So I just wanted to cover the vision and image generation in the first session and go into the other topics 3:30 to
Okay,
5.
sir. Okay.
That
You
was the
can
plan.
continue. Okay, sir.
Yeah, okay, sir. So now coming to the image generation part of it. So this is our second topic of this session. So how do we use AI to create synthetic images, or how do we enhance and the existing images? How do we add additional features to that? How do we generate? When we talk about generation, I'll go into various aspects of it. The when you look at the live examples, we can understand and appreciate that better. So how do we even generate voice? Either a text to speech is something that you have already seen already. So you might be listening to your various IVR messages, right? Those are all nothing but text to speech. For example, you call a bank, right? Your customer service. Then this is the next step of that. A text to speech is now getting converted to text to image. So those are the various topics. Text to video. Okay, so how do we do that? We will look into that in the next few minutes. So that is what this image generation is all about. So how do we get into this image generation using AI, right? So I'll just give a high level definition of this. We will cover in depth in the next one. A diffusion model is nothing but, we can, I'll give a layman terms example, I mean, definition of it, like remove unwanted material and make an image which is your objective or what you intend to do. That's your diffusion model. A GAN is nothing but how, I mean, if you look at the text definition, see, it's all about teaching. It's adversarial networks, right? When you say adversary, what does it mean? It's an enemy, right? But here it's used in a good sense. So you have two components of this. One is, how generate, and how do you differentiate and augment and make it better. So the two pieces of this is one of this talks about how to generate an image in a positive sense by giving more and more live examples. The other one is trying to differentiate between a real and a fake image. That way, in an iterative process and as it evolves, through the deep learning process, it evolves and it is able to better generate the images. That's about GAN. And diffusion model is about removing unwanted material and making an object out of it. So we'll go deep into that. So here again, image generation. So how do we, what all do we, areas do we use? This is not just limited to the examples I gave here. Application of image generation can be in n number of ways, right? For example, if you take the example of healthcare, right? You can create a demo video, right? Of how your, for example, your hospital is specialized in, a cosmetic surgery, right? A dental cosmetic surgery, for example. So how do you show that to people? You cannot show the live videos of teeth, for obvious reasons, right? People may or may not like it. But if you show an animated video of how things work, right? That's one good example. Education, right? You can prepare animated videos of how things work rather than, for example, a mechanical engineer. How do you show them how the machine works, right? The internals of a machine work. So creative industry, you can talk about creating various images for your advertising, so on, right? Okay, sorry. GAN is generative adversarial network. So here what it does is, when you take the literal definition of adversarial, right? It's adversary means an enemy, right? Here you take it in a positive sense. One part of that is teaching how to generate an image. The other part of it is through learning techniques, how to differentiate between real and fake. So here we feed data to that and teach them what is real versus what is fake. And the generative part of it, by giving more refined prompts. So I'll give some live examples here in a while. You'll understand how to prompt and generate using various AI tools. So the better, let us take a very simple example, a generation, how to, the prompting part of it, right? You call somebody and say, hey, can you draw a picture of a person? Even if it is a pencil artist, right? Even if you call your own kid and ask what do they do? They create a stick image, right? Head, legs, hands. If you call a proper artist and ask them, they will just draw a person, a generic person, right? Now the prompt, that is what comes into the picture. This is what is the, how do we teach the system what to generate, right? Now you say a person standing in a bus stop. You add more on top of that. Person standing in a bus stop wearing goggles. Okay, or a person holding an umbrella because it's sunny. Okay, then you might want to think of that person it might prompt the artist to draw probably a sun and a shade of the person standing there and all. See, this is all about adding certain features to that particular image. So this is how it evolves. The prompt part, the generation part of it, and the adversarial part, which is the how to differentiate between the reals and fakes, right? This is where you feed data and teach them what is real versus what is fake. So it comes more closer to the real world. Is that clear, madam? Sorry, I couldn't get your name. Who asked that question? So when we go deep into this, we will understand that. Okay. So here I will come to the different examples here. What are all the tools and all that we use? DALI, stable diffusion, and all that. Okay. So I'll get to this in a while. Okay. So before we get into the ethical considerations, let me take a quick pause here. Okay. I'll go to the what all we talked about here right away. Okay. Now, looking at some of the tools, the generation, right? I just fed this particular thing. This, if all of you have access to a computer, okay, I would like you to log into this website. It's a free site here. Let me just put that link in the chat here. You can all give it a quick try of this. Okay. So this stable diffusion is one image generator, right? So earlier I was talking about the prompts, right? When I spoke about it in theory, it didn't make any sense. Now, what I'm going to show you will make some sense, right? I'm just typing free text here, generate an image of beach. Okay, this is all I'm saying that. Please feel free to try this. Okay. So this is what I generated from its stock list of images, right? Now here, I'm just going to enhance this a little bit. Just saying with sunset backdrop. Okay. Just saying generate. Yeah, you can see here, right? It's showing a picture of a sunset as well. I can keep enhancing this, right? And a beach chair. I'm just saying, trying to add more features to that. Oh, I think this is a free version. So you're free to, try out more options here. You can keep adding that, adding more and more to the prompts. So this is how basically it works. When you say it tries to generalize things and it has stock images, right? It tries to, put up some image which is close to the description. I mean, earlier I tried that, it came up with this image. Beach, you can see in this image, beach, sunset, as well as a beach share, right? So basically, the more description you give, the better it would generate the image as per your requirement. So has anyone tried this now while we are on the call?
Yes, it's done.
Okay. So now let's add one more thing to this. I'm trying to make use of a Gemini tool, AI tool, right? So here I did two things. Create a prompt to draw a beach with sunset backdrop. So I hope you all can see what I'm typing here, right? And rather than here, what I did here is that I just typed a free text, right? As per what is going in my mind. Here, what I am doing is I'm asking Gemini to generate a prompt, how to feed the prompt to this particular website, right? So here I'm just asking it to generate. And people who have a chat GPT also can use probably chat GPT. So that would also give you the same kind of result. a similar result, right? So here Gemini is telling me how to write this in a proper way, right? In a better way, or if I should say. So it says a serene beach at sunset, sky is ablaze with vibrant hues of orange, pink, and purple. Soft golden light reflects on the calm ocean waves, right? Silhouetted palm trees line the shore. Lone figure walks in the water edge, right? Now, if I try to give this, see, we can use, okay, this is again a different site. Okay, so I suggest that we can, let me go to some other site here. I'm just going to 1 minute. I would like to show one more interesting thing here. Okay. So I made Gemini create a prompt for me, right? Now I'm using Microsoft Copilot here and just saying that generate an image, and I'm giving the same feedback here. The prompt that was generated by Gemini, right? Because it talks about orange, pink, and purple, you're getting all this. So this is how Copilot has understood my requirement, and it is giving a few more prompts, right? Now you see, palm trees, I drew them, a lone figure walking, right? Sky is ablaze with vibrant hues. So it has brought up all those features into this picture, right? So now when we think of practical application, we have two ways of doing it. When you generate the image, you try to be as creative as possible, or when you want an educational kind of thing, you have to stick with the definitions, right? You have to be as accurate as possible, precise as possible, with closest to the definition of the image you want to generate. For example, if it's an educational purpose, when it comes to a kind of a image that you want to generate for creativity purpose, like advertising, right? You have to be as creative as possible. So here is where you can take example of, you know, AI, right? Even the input that you are giving, you don't need to write everything on your own. Create a prompt, okay, to, or I can say, create a prompt to generate an image to show. I'm just saying college campus with, sorry, I'm just typing whatever comes to my mind right now. Okay, students, and I'm just saying playground. That's it. This is what came to my mind at this time. You can be as creative as possible. Okay, just here, instead of me thinking of how to write it more creatively, I'm taking the help of AI. Okay, so here I think it says it puts it hands up now, saying I'm still learning how to generate certain kind of images. So even this has its own limitation. Now I'm just saying, give me a, create some lines for advertising for an educational institution which offers. I'm just typing what comes to my mind, right? Which offers post graduation and placement. I just typed a few keywords here. That's it. right? This is not exactly about image generation, but I was just trying to give you some examples, right? As you keep giving keywords, right, it throws up some examples here. So Gemini at this time was not able to give me a prompt. Let me make use of Copilot here and say, create a prompt to generate an image of mountain backdrop with snow-filled peaks. See, it came up with some image. Thing is, I'm trying to make use of the same thing, asking Gemini now, generate an image, give the same input here. This is what it comes up with. Now, when it comes to your practical application of this in educational field, right? Now, you might want to, I'll come to the video part of it in the next session, but you can even give some prompts to this and create things like videos, right? And there could be an existing video. You can club videos within videos. You have n number of examples that we can put into use in the practical life. We'll come to that later. So here are some examples. Now, I want you to understand and appreciate the difference between this and Leonardo.ai. This particular AI tool, is developed on the basis of looking and studying at art. Okay, I think this is already open in a different site. Okay, so this has evolved over a period of time looking at various arts, the sceneries, photographs and all. So now I just take an example here. Okay, whatever we took from the previous site, right? A mountain range. Let's go back. I just want all of you to try this and this. You see the image generated by this, right? With just this simple prompt here. I'll give you the link to this as well. Right? Now, let me type the same thing here as well, rather than the other one. I just want you to understand the difference between these two. Of course, it has generated images here. We'll come to that later. But let's look at this one first. This could be little time taking, please bear. You see, when you look at this image and this image, can you please tell me, somebody unmute their line and tell me which one looks better? This is the Leonardo and this is the Stable Diffusion. Can somebody tell me which one looks better? Can I? Pick one. Okay.
It looks better, sir. Second one is better, sir.
Right. Leonardo, right?
Hmm.
So we were earlier talking about the learning techniques, right? In computer vision, we were image generation. Also, we were talking about various techniques, algorithms, right? Now, this Leonardo has been input with various art forms, scenic images, pictures that it is able to generate, a beautiful picture. When you look at these two pictures, this looks aesthetic, right? I mean, this looks like a camera trick. I mean, if we speak in a plain language, right, this just looks like a camera, a nice photography, rather than this telling you that this is a nice scenery, right? How did this generate is that this Leonardo, this AI tool has been fed with a lot of images and from by various famous painters, including Leonardo da Vinci, and it has learned a lot. So this is the basic difference between how do we teach the system and how to generate a better image. So here is where I was saying, if we are not able to be, we are not able to be so creative in explaining this, you can always take help of AI again and ask it to give us a prompt and use the same prompt and ask one AI tool to generate the same image. So again, I'm taking this same thing, right? This prompt. Now I'll just, I think I have already given it in the Leonardo tool, but if you look at this again, right? We'll just take a few seconds. Okay. So it's all about learning, right? And differentiating between real and fake images and so on. That what are things we discussed earlier. So you can see the quality of images that comes from, both the images, right? This is what was generated by Gemini. Okay, of course, this is an AI tool, but then again, this didn't work earlier. Pardon me for that. I have run out of the free credits on this site, but again, the quality when I generated didn't seem, superior to this. So when you use these things for educational purpose, right? We have these are just some examples. I'll send you an exhaustive list of various tools that you can use. And here is where we have different features of that. So again, we can make it cinematic. Okay, I'll just show you. I just change this, right? So just because we are doing a demo, I chose the a fast generation mode, just so all of you know. If I use these other features, it will take much more time. I didn't want to, go through the features of the tool a lot here, but at a high level, explain how these things work, right? So now it adds more and more features to this when we make use of, these options available here. You can make it a fashion, a minimalist, portrait. You can just say it looks like a professional black and white photography, so on, right? We can use all of these features. So I think, yeah, this is what we get for a free trial for now. Okay. So I'm using my personal account here, so obviously it has its own limitations. Okay. So these are the various things we can make use of. Even if you look at the other tool, right? It talks about creating the same image in an animation kind of a mode, like a photography, like a drawing, right? You have a lot of options here that you can make use of. Choose this. And currently, if you look at my selection is none. That's why it just came up, as is whatever it has in the stock image repository. I can make it convert into an animation, photography, so on, right? A comic, whatever options we have. Depending on your requirement, you can make use of all these settings here. Okay. I suggest that I encourage all of you to give these things a try, understand and how you can make use of various tools here and generate the images. Okay, so these are few more tools. DAL-E, the stable diffusion is what we saw. Again, NVIDIA Canvas. Leonardo is one more thing that I showed you earlier, right? Okay. Just take a brief pause here before I move to the next slides. Any questions so far? Okay. Okay, moving on. See, now this is a very important consideration for all of you as a teacher, right? So now we have to inculcate the ethical values into the students here and make people think and appreciate the ethical aspect of it when you make use of technologies. As we all know, technology can be used in any way for the benefit of greater mankind or destruction of anything at all. Now, just some examples here. A deep fake, right? You might have all heard of deep fake. One of a famous film actress getting impacted by that. Most of you must have read in the news recently, probably within the last year or so. So deepfake is all about making use of an existing video and superimposing somebody else's face on that and creating a fake, which for majority of the population who are not technologically aware might think that it's a real video, for example, right? And you have whatever malicious intent you have against a certain person, you can make use of all these technologies and get into those. Second thing is, when you think of image generation, you have certain thing in your mind as a human. We must all appreciate the fact that every human being is unique and everyone has their own lenience towards certain thing, right? Uh, again, people with some kind of a selfish motive, right? They can create these models with some bias based on their color, their creed, their caste, their religion, their ideologies, right? Anything. What is there in stopping me in creating a learning model which leans more towards let me say it, I'm a male, right? I just have some kind of an aversion towards females, progressing in any field. For example, I can make a tool create an image which only shows a male form for any kind of image generation that you're asking. If I say, show how advanced we are in rocket technology, these are just some kind of examples. I mean, I'm touching it at very the peak of it. I'm not going in depth, but I hope you understand where I'm going towards, right? It has more adverse effects of using these kind of biases in modeling of a particular tool. Again, the last one is about the IP concerns, right? Someone has created a nice video of something. I try to follow that using various techniques. I superimpose some other images and try to show and market it as if it's my own creation. Again, these are the high level challenges, ethical aspects of this image generation that we should all keep in mind. As we evolve more and more, nobody could think of certain things, certain unethical practices a few years back. As we progress more in technology, we are also coming across these things. These are just a few examples. We might come across a few more, which we should all be aware of and try to avoid. Now, when it comes to the challenges, right, in image generation, how do we? What are all the challenges that we already spoke about earlier? One is, how well you define the data dependency. Okay, how much data you have to create a certain image, right? You want to create an educative image showing the inner workings of, for example, a machine, a combustion engine, right? I'm not from that background where I can explain the workings of a combustion engine, but I want to create that. So I have a dependency on somebody who can explain me that concept better, right? These are the challenges. So when you want to go in depth about a specific topic, we need to have a good amount of data, the underlying data, to feed into the system that can give us an accurate picture of what we are looking for. And again, I might create n number of images and throw it on the web, right, for free usage. But where is the quality control? Who is looking into the aspect of whether what I generated is real or not, right? There are a lot of websites and all that you might know that create, even Google also we can mislead, right? Trying to make it point to my website as a popular website. So the same thing can come into picture in image generation as well. I can just say education purpose, some kind of images related to a specific engineering aspect or a medical field, and create a number of images and throw it out on the web. But where is the quality control? Am I really doing the right job there? So we have all these challenges that we should think of. And as and when the industry evolves, right, we might be able to overcome these things. Now, we already discussed these things earlier. How do we combine these two and make better use of it? Like, for example, augmented reality, right? Generate as well as analyze and come up with augmented reality, right? We have seen AR images. Unfortunately, I'm not able to show any of these here due to limitations. But again, we have seen, I don't know how many of you have seen the AR lens glasses, right? Virtual reality glasses, right? If you have seen that, I mean, I will not be able to give you a better experience rather than verbally explaining it. But it is better once you experience that yourself. So these are the various applications of how do we combine these two and give a better experience for bringing various better products into the market. Okay. Now, with our innovation and advancements, we can think of much more practical applications of this. We're already seeing a lot of cross-disciplinary things, right? Like how the example that I took in the very beginning, right? How a computer can help with the medical field. These are the cross-disciplinary impacts, right? So these are the various aspects of it. As and when as the industry evolves, we will come with more and more practical usages of this. So I just wanted to take a pause here and just leave the floor open for any questions. So I have already showcased the tools. I suggest that the examples that I gave earlier in the meeting were very primitive ones, the image generation and all. So most generic ones, and you can make use of the field of interest of your own and try for image generation on these websites. And I also have shown you how to create the prompts to generate the image as well. So you can make use of AI even for that as well, instead of you typing it on your own. Any questions? Okay, thank you.
Excuse me, sir.
With this, I just want to take a pause here before we go to the next topic. It's scheduled for 3:30. Would you all like to have a quick break and reconvene? What do you, Kameswara sir? Sir? Hello, sir. Kameswara sir. Should we take a break here, sir? And join back? Hello. Am I audible?
Yes, sir, you're audible, but Kamesh sir is. Once I'll convey.
Looks like he's on mute. Okay.
Sir said you can continue after 15 minutes.
Sure, sure. Would everybody like to continue on the same call, or do we have a separate meeting invite for that?
No,
Just
sir,
wanted
we'll be
to-
continuing in the same call.
Okay, fine. So, would like to take a 20-minute break. Shall we reconvene at 3:35? Is that fine with everybody? Almost
Okay, madam.
3:20
No,
now?
Sir, actually,
Okay. We'll take a 15-minute, quick 15-minute break. We'll reconvene at around 3:35. Thank you.
Okay, sir.
Okay, sir. Okay, no
sir.
problem.
I'll be continuing on the same bridge. Thank you.
Okay, sir. Okay.